Hello, Paulo Synthmania. Behringer very kindly sent in the 960 Sequential Controller. This is a classic unit, modern remake of famous sequencer from the 60s and 70s. Let's check it out. And in the box we have the 960 sequencer itself. Here's a view of the back of the unit. It looks like we have a trim pot here and the customary Eurorack connector. Also in the box we have the Behringer sticker and a 10 to 16 pin Eurorack power cable, 8 mounting screws, and a quick start guide, and this one is also available as PDF. Alright, we got the 960 hooked up to the Behringer Go Eurorack case, and let's talk about the controls a little bit, and then we'll listen to sound demos. And by the way, the width of the unit is 56 HP. The way this classic sequencer works, you have 3 rows, which 8 potentiometers on each, and each row is independent. Or if you have another module called the 962, you can actually treat it as a one full row of 24 steps. So right now we just focus on these 3 rows of each steps, and each of these buttons can be set to different values, different voltages, and these are also governed by these potentiometers here that go from 2 to 4 to 8 volts. You can change it here. These are the outputs in parallel for each row. So these are typically used to control pitch of oscillators. So according to how you move each knobs, it will give you a different voltage and so a different pitch of a note. But you can use them for anything else. You can control envelopes with them, filters, anything you want. On the top here, we have the frequency range. This is a master controller for the octaves, basically, of the frequency of each of the rows. And then a fine controller called the frequency vernier. You start the sequencer with this knob here, oscillator on, and you stop it with this black one here. And you can also control the start and stop remotely via other devices using these 2 inputs here. And the 960, as the original, has a built-in oscillator, and you can control it externally from the control input here, or also you can send the oscillator output here, which is useful to gate your envelopes. Now these knobs here that say skip, normal, and stop, per each stage, they control the mode of the stage. In normal mode, each stage will play, but if you skip it, it won't play. And if you set it to stop, it will stop right there at that stage. You can move through the stages by pushing each stage button. Or also with this shift button here, which shifts from stage to stage. Each stage has its own input and output, so you can send controls into each stage or send out per stage. Also, there's another pot here that you can set to skip or stop. If you set it to skip, it will keep rotating the sequences, but if you press it to stop, it will stop at the end of the sequence. And also a very important button here, it's a 3rd row control of timing. This is really cool function used by Tangerine Dream, and we'll see it later, for example. And right now it's off, but you can turn it on, and if you do that, the 3rd row of steps will not produce pitches, but it will be used to control the timing of the stages. So according to how these are moved, it will affect the timing between the steps. And that will create really cool sequences, and we'll listen to them in just a few minutes. Okay, let's zoom out for a second so you can see the whole path of the cabling. I have a very typical patch running here, and I'll describe what I have here. This purple cable goes from the output of the first row, controlling the pitch. It goes to the 1 volt per octave input of this oscillator here. And this blue oscillator output, it goes to a multiple, and then this brown cable and gray cable go all the way to these two ADSRs, one for the filter and one for the amplifier. Then we got this orange cable coming out from the saw output from the oscillator to a mixer, and from the mixer into a SEM filter, into the amplifier, and then out to the computer for recording. And so now the sequencer is sending note messages to the oscillator according to how these knobs are set, and gauge signals from the oscillator according to how the frequency range and the vernier is set. So let's say right now we can set these at random, and just like that, random, and set the frequency range, say a 4, and the vernier 5, and press the start button and see what happens. Very cool. And of course, as you change the voltage on the knobs, the notes will change. Change a note more by changing the amount of voltage that you send to the oscillator. So with this knob here, let's take a quick sample. And you have noticed that at the 8 volt setting, it goes so high, almost out of the auditory change, you cannot make up what the note that's being played. Now, these kinds of random high-pitched sequences are great for special effects, kind of to emulate the stereotypical sounds of a computer, such as But now, how can we achieve some more melodic lines? These are all analog controls, so unless you run this through a quantizer, which is a device that allows you to section each voltage according to the standard scale, you have to tune it by ear, or another method is to use an app, a tuner app such as this one here. And the way I do it, let's set the stop control here, so only one stage will play, and it will be a recurrent note, and we can tune it. And the way I typically do this, I set all the knobs to 0, and that I set it as the main C. So for example, on this note here, it says 0 if you play it. once you have set it to 0, you can kind of play with the fine adjustment on the oscillators so that you hit the note C, and that's calibrated. Okay, now we have the reference note set for each of the stages on the first row here, and I changed the patch. I set up a pulse wave with a little bit of modulation just to give the sound a little bit more life. So this is what we have so far. So now let's try to program, let's say, a major 7 scale up and down. So it's a lot easier if you have a quantizer. Right now I don't have a quantizer here, so it's fun to do it by ear. And actually the minor imperfection that you give to the sequencer make it sound really cool in a way. So let's try to build the major scale up and down. All right, now we programmed a major 7 scale. Hopefully it sounds in tune enough, and let's play it back. We can raise the tempo a little bit. And we can even give it a little bit of BigSky cloud reverb to make it sound really dreamy. Okay, let's do a few examples in the cosmic music of the 70s, such as Tangerine Dream and Klaus Schulze, etc. I programmed a couple of sequences on rows 1 and 2 in that style with the bass sound. Goes like this. And now, I don't have the sequential switch, but I'll do it manually so you can see how they used to switch from row to row. It's easy to do with the switch, but I don't have it right now, so I'll do it manually. Try to give you an idea of how it was done. And of course, then you would add a tape echo. In this case, I'm using a timeline from Strymon, and it would sound something like this. Now, the cool thing about the skip and normal section is that you can skip steps, and that also was used a lot in that style of music, such as this. Definitely 1970s flavor here. And now the cool function is the control of the timing. Also, this was done a lot. And it will change the timing using the third row when you turn it on. And again, it's a total Tangerine Dream feel. Combine it with skips. And another really cool effect that also was used a lot in the cosmic music of the 70s was the semi-quavers effect. They also call it ratcheting. But basically you have quavers, 8 notes, 16 notes, 30-second notes. You can change the timing. From another row, if you play the melody from this row, then you can change the ratcheting, the quavers, the semi-quavers from this row here. And that was also used a lot. And to do this, I'm using the great Vinicius Electric Lizard oscillator. And I am sending the CV gate to the Vinicius Lizard and going back with the square to the gates of the envelopes. And you get this type of ratcheting effect by moving knobs on the third row. You get the 16th notes, the 32nds, and 64th, and so forth. Really cool. It goes like this. And of course, you always put the tape echo on, and you get the classic sound. And we just scratched the surface of what the 960 can do. Again, you don't have to use it for voltage to pitch, to note, to create melodies. Not necessarily. You can use it also with filters to create variation in the filter, or envelopes. The sky's the limit, but I hope this gives you a good idea of what it can do with the melodies, which is a really cool aspect of it. Again, thank you very much to Behringer for sending a 960 in. Really appreciate it. And I'll see you guys at the next video. Thank you.